morning, students. So today I'm going to carry on forward with the third chapter of chemistry, that is atom and molecules. So I shall be taking this session with the starting of a new chapter, that is atom and molecules. So I guess every one of you have some sort of like rough idea about what atoms and molecules are all about. So before we talk about atom and molecules, we need to understand matter, right? So in class 8 we did talk about matter. Matter generally means any kind of object, whether it could be a chalk or could be a textbook, could be a blackboard, could be anything which occupies some sort of like space and which has some mass, right? So any kind of object that has these two kind of qualities, which we used to call this as matter. For example, even air is a matter because when we put the air into a balloon, it occupies some sort of space, and when we put the air into a football, it occupies some amount of mass. So we somehow classify the matter into three types here, that is solid, liquid and gases. Solid, liquid and gas. These are we used to call as three states of matter. So now this was the general idea which we are having it, but ever since long time back, okay, before like in BCs and all, there are great many philosophers who were like discussing about this matter and how this matter, what are the constituents of these matters and all of this. They were talking about this. So it was in 500 BC that there was a great philosopher from India. His name is Maharishi. His name is Maharishi Kanab. His name is Maharishi Kanab in around like 500 BC. Now this guy first started asking a question about, we have an idea about matter is having solid, liquid and gas. But what this solid, liquid and gas, what they are made up of. So this guy, his name is Maharishi Kanab, a great philosopher from India, started asking that particular question, and he came with a conclusion. That conclusion is this here. When we divide matter into tinier particles, that means smaller particles, ultimately we reach a stage when the matter cannot be divided any further. That means when we divide matter, that means, for example, this chalk is a matter. Why? Because this chalk is having mass and it is occupying some amount of space. Now when we divide matter into smaller particles, if I keep on dividing the chalk into smaller pieces, ultimately we will reach a stage when the matter cannot be divided any further, because if I keep on breaking the chalk down into smaller pieces and smaller pieces, there will be a stage where I won't be able to divide that particular small particles. And this particle, according to Maharishi Kanab, he named this particle as Parmanu, right? Parmanu. Is that clear? Okay, so this is just about how the history of atom and molecules, they are coming up, right? But around like the same kind of era, there is another guy, his name is Democritus. And Democritus, okay, let's say Democritus again. There is another guy, his name is Lysippus, okay? His name is, okay. He also said the same thing here, Democritus. He also said the same thing. That is, when we divide the matter into tiny particles, ultimately we will reach a stage when the matter cannot be divided any further. He also said the same thing. But what is the difference between Democritus and Maharishi Kanab is that he, instead of referring the name Parmanu, this guy Democritus called the name as atomos. Atomos. This word atomos, it means indivisible. Indivisible. Is that clear? So this is how we started with atom and molecules, right? This atom, the word came from the word atomos here, which means indivisible. Is that clear? Now this is just about the history of atom and molecules. Actually, there is a matter which has three states of matter, that is solid, liquid and gas. And this solid, liquid, gas, scientists and all these kind of great philosophers, they start pondering about what these matters are made up of, and they came with certain kind of conclusion like this one over here, and they named it as Parmanu. And there is another guy, his name is Democritus, he named it as Atomus, which is also referred to as indivisible, right? Okay. Okay, fine. Now with this, there are other kind of like scientists in late 17th and 16th, late 16th century and 17th century. Also, there are like many kind of scientists who begin to think more and more about the atom. And there was a great guy, his name is Antoine Lavoisier, who laid the foundation for a certain kind of laws which are related to atom and molecules. Is that clear? So now, since people begin to have more information about atom and molecules, they started forming certain kind of laws which are related with the atom and molecules. That law is called as law of chemical combination. Law of chemical combination. This law of chemical combination generally constitute two laws that are law of conservation of mass, and the second one is constant or definite proportion. Point here. So now these are the laws. Now, how we are relating these laws with the atom and molecule is like this here. Because previously we don't have any kind of idea about the atom and molecules. We have the idea of matter. Gradually, the philosophers begin to talk about the matter and what these matters are made of, and they begin to think about the smaller indivisible particle called atom. Now, these atoms, now they are not, staying in a singular manner. They constitute, like they form a chemical bond, they stay together in a group, or they form certain kind of compounds. Now they were thinking how this atom, the indivisible particle, they used to form with each other. Regarding that, they began to think about the certain kind of laws, that is the law of chemical combination, which constitute two laws, that is law of conservation of mass and the law of constant or definite proportion. We will first talk about law of conservation of mass. Okay, so now in this particular law here, this law was first formulated by the man called, he's a French, Antoine Lavoisier. Okay, he first formed this law, that is the law of conservation of mass. According to him, he gave two postulates in the case of law of conservation of mass. Number one, right? What he said, all matter. He said all matters arises from pre-existing matter. Pre-existing matter. So according to him, this first statement, what he was trying to say is that there is not something like a new kind of substance, because all the pre-existing, all the new matters which are being formed, for example, let's say this particular chalk, this is a new matter. This new matter is being formed from some other pre-existing matter, already pre-existing matter, which are being already there. This was his point, number one. Is that clear? I will make this clear when I give you one example here. Second one, the mass of the newly formed matter is constant to the Okay, So what they were trying to say is that now there will be a new kind of matter which is being formed. This new matter, it is having some sort of mass. This mass should be equal to the mass of the pre-existing matter with which this particular substance is being formed. So we will take an example in the case of law of conservation of mass. As I said in the previous class, that conservation, the word conservation, in my own word I used to say constant or not changing. Constant or not changing. Clear? So now let us imagine, okay, I wanted to make one banana shake. Clear? I wanted to make one banana shake. Now for me to make banana shake, what I have to get is I need to have banana, and I need to have, let's say, milk. Then I need to have sugar. Okay, so now these three constituents I'm going to use to make a banana shake. Now I cannot say that is banana shake a banana? Yes. Is banana shake a milk? Yes. Is banana shake a sugar? Yes. But you cannot say that banana shake is a sugar in particular. You cannot say that because sugar is not a banana shake. Sugar is present in banana shake, right? So now this is the newly formed matter. That is the newly formed matter. Newly formed. This is the pre-existing matter. Now let us imagine, okay, if I am going to use like assumptions, suppose if I am going to use 10 gram of banana and milk, let's say, normally you used to measure in liter and all of this, but for now we are going to measure 5 gram, sugar of 5 gram. If we use 10 gram of milk, banana, and 5 gram of milk and 5 gram of sugar, this banana shake, it will have a mass of 20 gram. Why? Because 10 plus 5 plus 5 is 20, this banana shake. So, according to Antoine Lavoisier, what he was saying is that all matter arises from pre-existing matter. That means this particular matter has arisen from the pre-existing matter like banana, milk and sugar. This is not a new thing because it has arises from the banana, milk and sugar. Is that clear? Now the second one, the mass of the newly formed matter, that means the mass of newly formed matter is 20, is constant, means equal, not changing, to the pre-existing matter. That means pre-existing matter combined together has a mass of 20 gram, which is equal to the 20 gram. That is why the law of conservation of mass, we used to say that mass can neither be created, mass can neither be destroyed, mass is always constant. Is that clear? This is the law of conservation of mass. Okay? Okay, let's go for the next one, that is the law of constant or definite proportion. Law of constant or definite proportion. I'm going to write here. Law of constant or definite proportion. This law was first given by Joseph Proust, which is why this law is also referred to as Proust law. Understand, this is also referred to as Proust law. Okay. So now, in this law of constant or definite proportion, what we need to understand is that this statement, what the statement was, in a chemical substance, in a chemical substance together okay. This was the statement given by Proust. Now we will try to understand this. What they were saying is that in a chemical substance, that means, let's say, suppose a chemical substance, in that, let's suppose imagine, okay, there is a chemical substance, say C, okay. This chemical substance is made up of certain kind of elements like A and B, okay. Now these A and B are made up of, C is made up of A and B, and A and B is present in C. I hope I'm not trying to make it more confusing to you, okay? Let's make it more simple. Let's just go for the example of banana shake here, okay? So now we made the banana shake here. Banana shake. Now I have given this banana shake to Mr. Tenzin here. Mr. Tenzin, okay? So Mr. Tenzin took the banana shake and he really liked that banana shake. So what he asked me now that he is going to bring two more of his friends. And he requested me to give me the same banana shake. Understand? So now previously when I was making this banana shake, I used banana of 10 gram, and let's say milk of 5 gram or sugar of 5 gram. I use this. This is 10, I'm sorry, 10. Okay? Now I have given these three constituents and I made a banana shake and I gave this banana shake to Mr. Tenzin here. Now Tenzin really liked this banana shake and he requested me to make another banana shake for him as well as for his friend, two of his friends. Now what I have to do is that if I try to use 10 gram and milk and along with the 5 gram of sugar, all three peoples, that means the three friends, they will get a little amount of banana shake. But I don't want this to happen, okay? Because they are going to have a glass. This is the glass with which Tenzin took the banana shake. Now I have to give this much full of banana shake to this guy also here. Okay? And to this guy also here. Fine. Is that clear? So now I have to give this. Now in order to give this, what I have an option is that I have to add some more banana and I have to add some more milk, I have to add some more sugar. Now what I will do is that in general case, in order to make the proper kind of taste, that means the same kind of banana shake which I had given to Tenzin, what I'm going to do is that I'm going to make another 10 plus another 10. This is for this guy here and this is for this guy here. And I will add another 5 and another 5 milk here. Then I will add another 5 plus another 5. So in short, for 3 person, I have to triple it up. Is that clear? So the banana shake which I made for all these 3 individuals, all the 3 is 20 gram and 20 gram. That is fixed proportion by mass. Is that clear? In short, if I give you another kind of example, is that let's suppose imagine we talk about ammonia here, ammonia, NH3, ammonia. Let's say 17 gram of ammonia. If there is a 17 gram of ammonia, we can somehow say there is a presence of 14 gram of nitrogen plus there is a 3 gram of hydrogen. In a chemical substance, the elements, that is nitrogen and hydrogen, they are present in fixed quantity by mass, that is 14 and 3 by mass. Is that clear? Similarly, in the case of, let's say, 9 gram of water, that is a chemical substance again, it has the presence of hydrogen and oxygen here. It has the presence of hydrogen and oxygen. In a chemical substance, all the elements, that is hydrogen and oxygen, they are present in a fixed quantity by mass. That is 8 gram and 1 gram of hydrogen, that is equal to 9 gram. That is the ratio of 1:8. This is how the law of chemical combination is all about in actual sense. Is that clear? So, law of conservation of mass mass like the case out the social humor and K ma the never said the K mass the kind of imbare de la mass of product set la mass of degrees. One. Then even the law of chemical combination is a show. Once the source calling kin never in a Katina Chukurang ratio because it begins 1:8 degrees. Kachini should be less than water H2O the chemical substance Shabina H2O. H2O in a career element new, that is hydrogen the oxygen. And Koraniga mass the Kazure, Niga 1:8 ratio of degrees. Neither the Kiranzola oxygen give mass the 16 mu down the day key makers on the atomic mass the idea the Ligurwa. Teens the Kiranzola basic idea to Chashavana. Nye banana shake, Missuna Tewena, Nila Michigan banana shake, Jedu Kugi, pay no Joboina, Nye banana shake 10 gram, Yangu Lupore, they got a new 10 chicola shower, 10 chicola shower, 5 chicola, 5 Choma shower, then a 5 chicola, day 5 to equal quantity of triple Machipoina tastes like the waters. So Katina chemical substance signal Katina mass 20 gram, Chipochigan lead Katina fixed proportion by mass liters. Thank you. Yes. So we were previously talking about the law of chemical combination. So there was a guy, his name is John Dalton, and he referred to the law of chemical combination. On the basis of that law, he proposed his own atomic theory, that is referred to as Dalton atomic theory. And he has given a very 6 important postulates here. Number 1, 2, 3, 4, 5, 6. So we will try to understand every one of this 1 to 6 one by one. So let us first try to imagine there is an element A plus there is an element B, and this gives rise to element C. Okay, compound C, I'm sorry, compound C. Now according to this, the first postulate, all matter, they are made up of tiny particles called atom. Now this particular matter is made up of the tiny particle of A and B. Is that clear? For example, even in this A case element here, this particular A is made up of a certain kind of atom, which are like totally indivisible over here. That is, atoms are indivisible. That is, atom cannot be divided any further. And this atom cannot be created or destroyed. Now to understand this, we need to think over here. If you look at this C here, this compound C is formed with the help of A and B. Now if I ask you, if you focus on this particular compound C over here, if I ask you where is A and B, you will somehow say A and B is present within the C, right? Because this C is made up of A and B. Now is there a new kind of atoms coming up over here? No, because this compound C is ultimately made up of A and B. So that means atom cannot be created. Now can you say that this A is missing in this? No, this A and B both are present in that. That means it cannot be destroyed. So there is no formation of new atom, and there is no loss of the pre-existing atom in that. Is that clear? Now the third one, the atom of a given elements are identical in mass and chemical properties. Now we have two elements here, that is A and B. Let us try to zoom this A. Zoom out. We are zooming out. When we zoom out this element A, we will find a small amount of atom A in that. And all these atom here, all this atom which are present in this particular element A here, A. All this A, they are identical in size and they have the same kind of chemical properties. Is that clear? Now, if you try to refer A with B, they are completely different. Why? Because A and B are totally different here. That is the fourth one. Atom of different element, that is A and B are different element, have different mass. Now this B, if you look at this B, we are going to zoom out this B here. Now this B, if you look at this B and this A, they have different mass and their chemical property is totally different. So on the basis of that, 3 and 4 can be understood. Now, let's go for the fifth one here. In the fifth one, atom combine in simple whole number ratio to form compound. For example, let us think about water. In the case of water, there is a presence of simple whole number ratio of 2 hydrogen and 1 oxygen. That is whole number. You will never see whenever there is a formation of a compound, there is a half molecule or quarter molecule of this and 1/4 or 3/4 or whatever it may be. There won't be anything like this kind of like ratios over here. Is that clear? So the atom combine in simple whole number ratio to form compound. Now the third one, sixth one is the relative number and the kind of atom are constant in a given compound. For example, let us think about this is somehow similar to the law of constant proportion or definite proportion, which somehow says that water is present in the ratio 1:8. It doesn't matter where its source is, where it comes from. Types are, the chemical formula is 1:8, that is in the ratio of H2O, that is in the mass of 1:8 here. So the relative number and the kind of atoms are constant in a given compound. Let's say water is a compound, H2O. This H2O has a relative number and the kind of atom present is always in the ratio of 1:8. Is that clear? So this is just about the Dalton atomic theory. So Dalton atomic theory ne ngajek ja kha shigol na matter le di ngajek atom ki su yu le law atom ki pitchin ju le ani atom di ngajek kha law le divide che yo mane an saw se yo mane ma never se yo mane penetration de la compound C na yu na la e the B ni la C na yor de yang kena ki dina la saw form chigol na saw ke form chigol mane kai la di e the B ki drup shaki di C chawol ba. Okay, somebody this is also the age book in level na a dina na yu ge atom ka ki science ta mass ta chibal re an ko ji ani chemical property chibal re in a the B ni bad different real ani atom combine in simple whole number ratio to form compound kati na manzo quarter la da 3/4 la da 1/4 la ne ki the compound se shaki ne ki yo mare la kati na ratio ya na 2:1 1:2 1:8 whole number simple whole number ratio na li is ani ta thama dikhala hola na manzo ki compound chikina la kati na atom kurang ki kind here one number the ratio ti kati na chipa chikyam li re kati na constant li re la that's all to